Okay, I know what you're thinking. What other kinds of functions are we going to study in this functions unit of pre-calculus? I'm glad you asked. Two more families. Exponential functions, which you probably remember a little bit from Algebra 2. There's a very basic exponential function, and you can pretty easily analyze the behavior of this function. We can see that a simple table of values, if you plug in 0 for x, we get 2 to the 0, which is 1. Anything to the 0 power is 1. And if we plug in 1 for x, we'll get 2. If we plug in 2 for x, we'll get 4. And then if we start plugging in negative values for x, 2 to the negative 1 is going to be 1/2. And 2 to the negative 2 is 1 over 2 squared, 1/4. So you can see that no matter what negative value I put in for x, I'm never going to get a negative output. So as x increases, then y increases exponentially. And then as x decreases, then y also decreases, but it never becomes negative. Right? So we have a horizontal asymptote here, right? The function's never actually going to reach 0. So just like other kinds of functions, exponential functions, we can take their equations and do transformations on them. So consider these variations on 2 to the x. Okay, y equals 1/2 to the x. That is, of course, equivalent to 2 to the negative x. Just use a simple law of exponents, right? To the negative x, to make that exponent positive means I would flip this and make it the reciprocal 1 over 2 to the x. And that variation is going to take this graph of 2 to the x and flip it over the y-axis. Right? So instead of being an exponential growth model, it's going to look like this. Okay? Same exact outputs as 2 to the x, except for it's reflected across the y-axis. Okay? Same y-intercept of 0, 1. Okay. Okay, so in general, for an exponential function, we have this equation. Some rate of growth, in this case 2, some rate of growth raised to the x power. We can multiply the entire function by some factor if we like, okay, which would stretch it vertically as we're used to. We can also change the inputs in various ways. We can make the input negative, which would flip it over the y-axis. We can add or subtract values to that exponent, which would shift the graph right or left. And we can also add some value to the outside there. So we can see that if we take this parent function 2 to the x and, for example, add 3, that's going to shift this entire graph up 3. Okay? And if we shifted it down 4, it would shift the entire graph down 4. So that this number b represents the horizontal asymptote of our exponential function. Okay, and this value a represents the vertical stretch. And if we alter the inputs in any way, the same rules apply as did for other functions. We can stretch or squish the function horizontally, or we can shift it right or left by altering the exponent right here. So If I give you a graph like this, oh, I don't know, negative 1/2 to the negative x. We can put its graph together in lots of ways. Of course, you can always just make a table of values, plugging in x's and seeing what you get for y. But we can also figure this out from a simple transformation. We know that 1/2 to the x power looks like this. And then if we consider the first negative sign on the outside, that's going to flip it upside down. So it'll look like that. Y-intercept of -1 now, still a horizontal asymptote of 0. And then if we consider the negative on the exponent, that's going to flip it over the y-axis. So we're going to get a graph that looks like that. Okay. So exponential functions have this form, and we can transform them. We can see whether we're looking at a growth or a decay model based on transformations. This is a decay model because we've flipped it and flipped it. Okay, back to 2 to the x. Do this in blue. Okay, there's 2 to the x. Notice that this is a function that has an inverse. It is invertible because I can do, well, first of all, it's a function. The vertical line test works, so it is a function, but also I can do a horizontal line test and see that the reflection of this is going to be a function. So this has an inverse, and I can sketch it. And instead of having the point 0, 1, it will have the point 1, 0. Instead of having the point 1, 2, it'll have the point 2, 1, and so forth. So it's not difficult to sketch. And whereas this original function has a horizontal asymptote at 0, the inverse function here is going to have a vertical asymptote at 0. So we're able to sketch the inverse of an exponential function, but what is the equation of that inverse? Well, for one thing, we know we would have to switch the x and y values and then solve for y. So here we go. Swap the x and y. X equals 2 to the y. But now we have to solve it for y. And how do we do it? If you recall, we can